If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level on ellipse. So today we will build concepts on perpendicular tangents, how we can draw perpendicular tangents to an ellipse, and we will see the idea of the diameter circle in case of an ellipse. Okay, then let's see this. Okay, the next article is perpendicular tangents and diameter circles. So from the last article, if we extend it a little bit, we can see we have decided depending upon the values of d how many tangents we can draw. Now suppose we are drawing two real tangents, that means this condition t is greater than 0. So if I want to take the product of m1 m2, the product of the roots, so what is the product of the roots in case of quadratic? It is c by a, m1 m2, this is c, this is a. So if I want to take the product of these two, m1 m2, that should be equal to c by a. C is here this one, a is here this one. This c by a coming from quadratic equation. So this. Now because you are saying that the tangents you want to draw, that should be perpendicular, both the tangents, whatever tangents you are drawing to this parabola, they should be perpendicular. They should be perpendicular. This tangent should be perpendicular. So in case of perpendicular, this m1 m2 should be equal to -1, because product of the slopes becomes -1 in case of perpendicular tangent. So this should be equal to -1. So if you open it, it becomes an equation of circle of this format. So what does this represent? This is known as diameter circle. So you will come later. This represents the locus of all points from which you can draw perpendicular tangents, because you can see if a point, you got a point, what was x1 y1, this was the point from which you are drawing tangents. Now because you are drawing perpendicular tangents, that means this is the x1 y1 represents all points from which perpendicular tangents can be drawn, all points from which you can draw perpendicular tangents to the ellipse. So you can think of this equation represents, if I take this point as hk, so hk should satisfy this. So that means h square plus k square equal to this. That means the locus. Okay, this is a circle. Locus of all points from which you can draw the perpendicular tangents to the ellipse. And that locus we always know, that is known as diameter circle. So this is the equation of the diameter circle in case of a ellipse. Recall again your circle. If had it been a circle, in case of circle, what was the diameter circle? X square plus y square was 2a square, because in case of circle a and b were equal. So a square plus a square, it was 2a square. So there is a similarity between circle and ellipse, you can see. If you like the video, then press the like button and please give your valuable comments in the comment section.